we are covering steel connections for the FE civil exam, focusing on the critical differences between bolted and welded connections. The NCEES exam will absolutely test your ability to distinguish between bearing type and slip critical bolted connections. In a bearing type connection, the load is transferred once the bolt shank makes direct contact with the edge of the bolt hole. Think of it as a direct push. The strength is therefore governed by the bolt's resistance to shearing and the plate's resistance to the bearing pressure from the bolt. In contrast, the slip critical connection relies on a completely different mechanism: friction. High-strength bolts, like A325 or A490 types, are pre-tensioned to a very high tensile force, which clamps the connected plates together so tightly that the friction between the surfaces prevents any slip under service loads. The load is transferred through this friction, not by the bolt bearing on the plate. The exam will signal a slip-critical problem by mentioning oversized holes, slotted holes, or specific surface preparation requirements, as these are situations where preventing slip is paramount. When you encounter a connection problem on the exam, your first step is to identify the connection type. For a bearing connection, you must check multiple failure modes, primarily bolt shear and plate bearing. You can find the governing equations and material properties in the steel chapter of the NCEES FE Reference Handbook. A classic exam trap is to forget to account for the number of shear planes. If a bolt connects 3 plates in a lap splice, it's in double shear, and its shear capacity is doubled. Another common mistake is confusing the nominal shear stress, FNV, with the nominal tensile stress, FNT, from the tables. Pay close attention to the loading condition. The bolt type is also critical. Group A bolts, like A325, have lower strength than Group B bolts, like A490. Using the wrong table column will lead you straight to a distractor answer. Now, let's shift to welded connections, which are tested just as frequently. The most common type on the FE exam is the fillet weld. The strength of a fillet weld is not determined by its leg size, but by its effective throat thickness. Here is your memorable phrase for welds: the throat is the weak spot. For a standard fillet weld with equal legs, the effective throat is calculated as 0.707 times the weld leg size. This 0.707 factor comes from the sine of 45 degrees, representing the shortest distance through the weld. A typical exam question will provide a connection detail, a load, the weld electrode strength such as E70XX, and the weld leg size. The 70 in E70XX tells you the weld metal has a tensile strength of 70 ksi. Your task is often to calculate the required total length of the weld. The capacity of the weld is its effective area, which is the throat thickness times the total weld length, multiplied by the allowable shear stress of the weld material. The number one trap here is using the leg size instead of the throat size in your area calculation. Always calculate the throat first before proceeding with the strength calculation. The nominal shear strength of the weld metal is typically taken as 0.6 times the electrode's tensile strength, FEXX. Make sure you use this factor when determining the weld's capacity per unit length. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.